So the moving shadow problem says we have a woman that's 5 feet tall, not particularly tall, and she's walking at a certain speed toward a street light that is 20 feet above the ground. It says, find the rate of change of the length of her shadow at a certain time. And then it says, at what rate is the tip of her shadow moving? Okay. So I'm going to try and draw a sketch because I think because there was no sketch and you haven't seen this kind of problem, there's my 5 foot tall woman. You don't like her outfit? Come on. She's walking towards a street lamp which is 20 feet tall. So let's see, 5, 10, 15. There's my street lamp. You guys with me? And we're supposed to find at what rate the length of her shadow, is that what they said? The length of her shadow. Where's her shadow? That was part of the problem. See, the light shines on her, just like it shines on everyone. But then, like, just past her, from here to here, there's a shadow. Are you with me? Actually, it kind of looks like this. Right? That's her shadow. Right over here. And I'm going to call that X, the length of her shadow. X is the length of her shadow in feet. Why did I choose feet? Well, because they told me she is 5 feet tall, and they told me this light is 20 feet in the air. How many are with me so far? Okay. And what is it that we're actually supposed to find based on this schematic? We're supposed to find, that's the problem. Trying to understand what you're supposed to find. Here, let me go back to the text. Where'd it go? Here? Moving shadow. It says, what is the rate of change of the length of her shadow? In other words, find what? Find dx dt when something else happens. When what happens?
She's 15 feet away.
She is 15 feet from the street light. Now hold on a second, just so you guys understand. I labeled this X because, do you guys understand the length of the shadow is going to change? Sure. Matter of fact, right when she's directly under the street light, it'll be 0. And it'll start growing again. You guys with me? So because she's walking towards the street light, the shadow changes until it gets to 0. Let's call this distance Z from the woman to the light. Is that okay? We're supposed to find dx dt when Z equals 15. Guys with me? And there's only one other thing that they told me in the problem. What's the other piece of given information? Oh, here it is. She walks 8 feet per second toward the streetlight. How would I express that? If she's walking towards the streetlight, what does that mean is changing? Yeah. So I might say dz dt, we are given that dz dt is equal to, they said 8. Why don't I say negative 8? Do you understand why I would do that? Why would I say negative 8 feet per second? Well, because Z is getting smaller. 8 feet per second small. Are you guys with me? So actually, if she's only 15 feet away, less than 2 seconds from now, that shadow's gone. Right? It'll take her less than 2 seconds to cover the 15 feet if she's going 8 feet per second. Question? No? The trick now is How do I set up a related rates equation? I need to see how dx dt and dz dt are related. For that, you have to know how x and z are related. And what's the key to this problem geometry-wise? What? You see similar triangles? I used to take my geometry class in high school out to go measure. We would measure the height of the goalpost. There'd always be some kid that was 5 feet tall. They were sophomores in high school, so we'd get that person, and then we'd line them up, and we'd do this problem basically. So yeah, the triangles that are similar are this one to the big one. Okay, and because those are similar, you can say that certain sides are in proportion. So I could, for example, say that x over 5 is equal to, well, now I have to do the big triangle. What do I put over 20? X plus z. That's right. X plus z over 20. So there's an equation. And what am I going to do eventually then? Take the derivative of both sides with respect to time, t. And then you'll have a related rates equation. I wouldn't do it yet. I would do this. I would mess around with it a little bit, you know. 20x equals 5x plus 5z. So 15x is 5z. So I'd say, hey, z equals 3x. Well, that's kind of interesting. Once you know that, you know how long her shadow is, right? Z is 15, and her shadow is 5. That's actually the same length as she is. So it's right when it's at a 45-degree angle is when they decided to stop the problem. Out of time, guys. You can solve the rest at this point. So this is the one about filling a hemispherical tank, okay? And so, you know, I guess I want to draw what they have, and I'm going to label some things. And then, again, their hint is that the volume of a cap of thickness h sliced from a sphere of radius r is, and then they give it to me, h squared times 3r minus h over 3. And that's what got me.
Did you get the pi in there?
No, I missed the pi, thank you. But that makes sense. Pi h squared, pi r squared kind of thing. So this was their hint, all right? And there was a couple more details that I should include. So one thing was they talked about there's water coming in at a rate of, wasn't it 3, I don't remember the units, let's take a peek. Meters cubed, 3 cubic meters per minute, right? And what I said that is, that's dV dt, right? And a couple other things they told me. They told me that this tank, they had a picture here, they said that this radius was 10 meters, right? And this is a hemisphere, which means that really this is also 10 meters, correct? So it's 10 by 10. Now, where's the water? Well, the water is partway up, always. And so this formula here is supposed to help me find the volume of the water in the tank. You guys with me? So how high is the water? Well, I'll call that H. Now, what got me yesterday was this. I called this radius R, which is good. But there was a problem. And the problem is, this R is not the same as that R. Because that R is the radius of the sphere. Is this thing a sphere? No. This is the radius of a circle. You guys with me? That's what killed me yesterday. Matter of fact, I almost feel like I should call it something else so I don't get into trouble. Why don't I call it X? So that'll be X. The radius of the circle, of the puddle. Now, the volume of the water is this, right? I have this formula, but I want you to notice something. Notice H is changing. Correct? And actually, I think what they want me to find is dH dt. Is that right? Let me just double check that. It says, yeah, look at the question. How fast is the water level rising? Right? That's dH dt. Right? So really what we're supposed to do is we need to find dH dt. But here's the mistake I made yesterday. Notice R is not changing. Matter of fact, what does R equal? 10. R is the radius of the sphere. Now X is changing. If they ask me about X, I could do that. I think you actually need to do that for the problem you got assigned. Problem 33, you'll need to deal with X. Because I think they want to know something about the area of that surface of the water. What is the formula for the area of the surface of the water? Pi, well, it's going to be x squared if I use x. But yeah, that's it. You guys with me? So, anyways, I need to find dH dt. But my formula, coming from this box then, would be the following. Volume equals, how about I say 1/3 pi h squared, and then what do I put in parentheses? Well, it's not 3r minus h anymore, because I know what r is. R is 10. So I can write 30 minus h. Does that make sense? Question, Chris? What I did was, instead of writing it this way with the divided by 3, I just thought, let me put the 1/3 out front. And why did I do it that way? Because what I'm about to do next. As a matter of fact, let me rewrite it in black so you guys can see it better. I'm going to distribute. So I'm going to take this big mess, and I'm going to distribute it. So let's see. 1/3 of 30 is 10. So I have V equals 10 pi h squared minus 1/3 pi h cubed. So that's the volume of the water. And now what am I going to do to both sides? I'm going to take what? The derivative with respect to t. Okay, here I go. When I take the derivative with respect to t, I get dv dt equals, well here, let's write the 10 pi down again. That's just a constant. And then I get 2h dh dt minus, let's write the 1/3 pi down, times 3h squared dh dt. See that? And what this is called, this right here, is our related rates equation. because it shows you how dv dt is related to dh dt. You guys have questions? So what's the next step? What's that? We want to get dH dt by itself? Sure, we could do that. I mean, I guess I could say that this equals, because I already have dH dt on this side, right? It's dH dt times a bunch of stuff. Let's see what it would be. This is 20 pi h minus, and this is just pi h squared, right? Because the 3's cancel. And this is equal to dv dt. Okay. But again, I'm supposed to find, here, let's look what the problem asks again. It says, and go back to it, it says, how fast is the water level rising when the water level is 5 meters from the bottom? So in other words, what did they give me there when they say the water level is 5 meters from the bottom? That's h, right? So we know a couple things. We can fill in a 5 everywhere there's an h. What else can I fill in? What is dv dt? We know that. Yeah, that was up at the top, right? They told me how much water's coming in per minute. 3 cubic meters per minute. And so this is 3 cubic meters per minute. And since this was in cubic meters per minute, that actually tells you what dH dt is going to be in. So now to finish the problem, I'll just do this. I'll say dH dt equals 3 divided by this big parentheses. The big parentheses looks to me like it's 100 pi minus 25 pi, right? So the answer, dH dt, is 3 divided by 75 pi. Let me get a decimal value for that. I'd like to know about what that is. So let's see. Second quit. Let me go here and let me type in 3 divided by 75 pi. So I'm getting 0.125. And what are the units? Or 0.126. The units would be meters per minute. Meters per minute. Okay? Now, actually, to make it realistic, this isn't quite the right picture, right? It's close. The right picture would be, again, if this is a 10-meter radius tank, so that's 10, that's 10, the water level is halfway up, 5, right? And by that point, it's only rising 0.1 meters per minute, and that's giving me an extra 3 cubic meters of water per minute because this is so wide. If you had calculated it, say, when h was 1 meter, look what the difference would be. You'd get 20 pi minus pi, so 19 pi. You'd get 3 divided by 19 pi. Let me do that. So when the height is 1 meter, now it's really filling up faster. It's filling up a ½ meter per minute. And then it slows down because the tank's getting wider as the water level fills up. Okay?